So in this video, what I wanted to talk about was volume by disks or washers method. Now, in the last video, we talked about solids of revolution having that kind of circular base to them. They involved an edge that was rotated all the way around and was consistent for the whole shape. And so in this case, what I want to do is I want to kind of extend what we're talking about with solids of revolution to talk about how to find the volume of those solids. So here's what I'm going to do. Excuse me. Volume by disks and volume by washers are very, very similar to the way we did areas of curve or area between curves or area of one curve, as well as it's very, very similar to the way we did cross sections because all of these are geometry based, and so they're all going to be similar. What I'm going to do first is I'm going to talk about the disk method. And so what I'm going to do is I'm going to draw very quickly just a curve, and it doesn't really matter what the curve looks like. I'm just going to draw a curve. When I rotate this around the x-axis, and you can do it around the x, you can do it around the y, it doesn't really matter which way it's rotated. What I'm going to get is something that looks almost exactly the same. It's just going to be rotated, okay? And so it's going to look something like that. You know, I'm not the perfect artist, but it's going to look something like that. And so if I were to take this curve and rotate it, it's going to look like this all the way around. No matter if I turned it or rotated it in any way, it's going to keep the same shape. And so what I'm going to see is if I were to cut this in half, I'm going to see a circle that is inside of this, and it's going to be a solid circle, okay? And it doesn't really matter where I cut this, they're all going to be solid circles. And so that's kind of the important part here is they're all just flat circular discs, okay? Now that I've mentioned that, here's where we're going to go from there. Again, they're circles. I'm combining circles over and over and over again. So essentially what my volume formula is going to be is that area formula, pi r squared. I'm just going to use the integration of it because I'm going to combine all of the circles of various sizes together to make this one beautiful 3D figure that I want. And so again, if you're rotating around the x-axis, you're going to write the radius in terms of x's. If you're rotating around the y-axis, in case that happens, because that does happen a lot, you're going to write your radius in terms of y's. Now, that I've mentioned the disk method. I'm also going to go ahead and mention the washer method. Now, if you notice here, the radius essentially was just either the top or the bottom function. In this case, and when I talk about washers, I'm generally using two functions, okay? So I'm just going to kind of draw two functions real quickly. So here I go. I'm going to draw one there, and I'll draw one here. Now, when I rotate it, and again, I'll just do this the same way. I'm going to rotate around the x-axis. I'm going to get something that looks very, very similar, just rotate it around, and it's going to have this shape all the way around. In fact, this is going to kind of look like a bowl that's not curved in, but has kind of a curved out both on the outside and on the inside. I guess you might call it a bird bath, kind of a shape to it, or maybe a flower. But if I were to slice this open, if I were to make a cross section of this, what I would have is a circle with a hole in it. Again, if I were to slice this up here, I'd have a circle with a hole in it. So what I'm getting are these slices that look like this. Again, this is called the washer method because, hey, that's actually what this is called. If you have ever worked with your hands or done any kind of woodworking or metalworking or any of that kind of stuff, you would see these metal rings that are called washers that you usually put on when you're combining wood or other things like that to protect the material from screws, nails, bolts, etc. That it just provides an extra layer of protection that it's not going to go all the way through or pierce. And so those are very, very helpful, but that's essentially what we're doing is we're going to have two curves that make a donut shape kind of feel to them. Or you might even call it a CD, but we call them washers. It's volume by the washer method. Okay, and so here's what I've got. I've got, in this case, an outer radius, which I'll call capital R because it's bigger. Okay, again, capital R because it's bigger. And I'm also going to have an inner radius, which I'll call little r because it's going to be smaller. Okay, so what again I'm going to do is this is still a circle. This is still a circle, so I'm still going to essentially use the same formula. I'm just now going to rewrite it a little bit differently. So I'm still going to integrate from A to B. I'm still going to integrate across that whole thing. And I'm still going to multiply by pi r squared. But what I'm going to do is the big R squared minus the little r squared. Okay? So that's the important part here. Now notice I'm not doing big R minus little r squared. I'm doing big radius squared minus little radius squared. Remember, again, hopefully you guys remember that these two things are not the same. They are not the same. So be careful. This is the one we want. We don't want to use that one, okay? Hopefully that helps explain what we're going to do, because I'm getting ready to do some examples in the next couple videos. Hopefully that helps. See you in a minute.